Here's something that's going to blow your mind about ancient philosophy. We're about to meet a guy who lived 2,600 years ago, Anaximenes of Miletus, and this man had the audacity to look up at the sky, look down at the earth, look at his own breath, and say, "I think I figured out what everything is made of." Now, I know what you're thinking. Great, another dead Greek guy with a weird theory. But hold on, because what Anaximenes did wasn't just propose some random idea about the universe. He did something revolutionary. He took the biggest question humans can ask, what is reality? And he tried to answer it without gods, without myths, without supernatural explanations. Just reason, just observation, just one guy and his brilliant, flawed, absolutely fascinating theory. Look at these dates. C. 586, 525 BC. That's the 6th century before Christ. Think about what the world was like then. Most people explained thunder as Zeus being angry. Earthquakes? Poseidon throwing a tantrum. Disease? You must have offended some deity. But Anaximenes? He said, what if there's a natural explanation? What if we can understand this? This is the birth of science, folks, right here. Not perfect science, we'll see the limitations. But the method, the approach, the sheer intellectual courage to say, I'm going to figure this out using my mind, that's what we're celebrating today. And his answer? Air. Everything is air. Which sounds ridiculous until you actually hear his reasoning. Then it sounds, well, it still sounds a bit ridiculous, but also kind of genius. We'll get there. The subtitle here says, Pioneer of Natural Philosophy, and that word, pioneer, that's exactly right. A pioneer doesn't get everything right. A pioneer goes first. They make the path. And Anaximenes? He's hacking through the jungle of human ignorance with nothing but his brain and his observations. So as we go through this lecture, I want you to do something for me. Don't judge Anaximenes by whether he got the right answer by modern standards. Judge him by this. Did he ask the right questions? Did he use a method that could lead to truth? Because if the answer is yes, and I'm going to argue it absolutely is, then this guy deserves a standing ovation 2,600 years later. Okay, let's get some context here because Anaximenes didn't just appear out of nowhere. He's the third member of what we call the Milesian school, and this is one of the most important intellectual lineages in Western history. First, we have Thales. Now, Thales is the OG, the founder. He's the one who started this whole crazy project of trying to find the fundamental substance of reality. His answer? Water. Everything is water, which, if you think about it, isn't terrible reasoning for ancient times. Water can be liquid, solid ice, gaseous steam. It's everywhere. Life needs it. Not a bad guess, Thales. Then comes Anaximander, Thales' student, and Anaximander says, nah, my teacher got it wrong. It can't be water, it can't be any specific thing we can see or touch. So he proposes something he calls the apeiron, the boundless, the infinite, the indefinite. Some kind of primordial substance that's more fundamental than anything we experience. Now, this is actually a sophisticated move philosophically. Anaximander is saying that the ultimate reality might be something we can't directly observe. That's abstract thinking. That's getting deeper into metaphysics, and then we get to our guy, Anaximenes, student of Anaximander. And here's what's fascinating. Anaximenes looks at his teacher's theory and says, you know what? That's too abstract. We need something we can actually work with, something we can observe transforming. So he goes back to proposing a specific substance, but not water like Thales. He chooses air. And here's the brilliant part. He doesn't just say everything is air. He explains how air becomes everything else. He gives us a mechanism, rarefaction and condensation. Do you see what's happening here? This is how knowledge actually develops. It's not a straight line to truth. It's a conversation across generations. Thales says, one substance, water. Anaximander says, good idea, wrong substance, it's the boundless. Anaximenes says, right direction, but let's make it observable, air with a mechanism. This is dialectic in action. Thesis, antithesis, synthesis, each thinker building on and critiquing the previous one, and they're all from the same city, Miletus, this incredible hotspot of intellectual activity in ancient Ionia. Picture this place. Miletus is on the coast of what's now Turkey. It's a trading hub. Ideas are flowing in from Egypt, from Babylon, from Persia. You've got merchants, travelers, different cultures mixing. And in this cosmopolitan environment, you get people who start questioning the old stories, the old myths. Here's what I want you to understand about the Milesian school. These three guys, Thales, Anaximander, Anaximenes, they're not just proposing theories. They're inventing a new way of thinking. They're saying we don't have to just accept what the priests tell us or what the poets sing about. We can figure things out. And yeah, they got a lot wrong. Spectacularly wrong by modern standards. But they got something profoundly right. The method. Ask questions. Observe nature. Propose explanations. Debate. Refine. That's science. That's philosophy. That's the beginning of the Western intellectual tradition. So when we look at Anaximenes, our focus today, we're not just looking at one guy's theory about air. We're looking at a crucial link in this chain. We're seeing how human beings learn to think systematically about reality. And trust me, when we get into his actual theory, this rarefaction and condensation business, it's going to make you see your own breath differently. It's going to make you think about change, about transformation, about how one thing becomes another. Because here's the thing nobody talks about. Anaximenes is trying to solve one of the deepest problems in all of philosophy. If everything is fundamentally one thing, how do we get diversity? How does the one become the many? How does air become fire, water, earth, stone? That question? We're still wrestling with it. Different language, different tools, but the same basic mystery. So let's dive deeper into who this guy actually was, what his world was like, and why his particular moment in history made his theory possible. Alright, so who exactly was this guy? What do we actually know about Anaximenes, the person? And here's where I have to be honest with you, which is going to be a theme throughout this lecture. We don't know a ton. The ancient sources are fragmentary. We're piecing together a life from scattered references written centuries after he died. But what we do know is fascinating. Born around 586 or 585 BC in Miletus. Now, I mentioned Miletus before, but let me paint the picture more vividly. This isn't Athens. Not yet. Athens is still relatively insignificant at this point. Miletus is where it's happening. It's one of the most important cities in Ionia. That's the Greek-speaking region on the coast of Asia Minor, modern-day Turkey. And here's what's crucial. Miletus is rich. It's a major trading port. It has colonies all over the Mediterranean. This matters because philosophy, real sustained philosophical inquiry, requires leisure. You need people who don't have to spend every waking hour just surviving. You need a merchant class, an educated elite, people with time to think. So Anaximenes grows up in this environment of wealth, trade, cultural exchange, and, this is key, intellectual ferment. Because remember, Thales and Anaximander are already there, already asking these big questions. Student of Anaximander, this is huge. This isn't just some guy randomly coming up with ideas in isolation. Anaximenes is part of a tradition. He's in a teacher-student relationship with Anaximander, who was himself connected to Thales. Think about what that means. Picture young Anaximenes, maybe a teenager, maybe in his 20s, sitting with Anaximander. And Anaximander is explaining his theory of the apeiron, this boundless, indefinite substance. And Anaximenes is listening, nodding, thinking, and then he starts to push back. Teacher, I respect your theory, but I have some questions. This is how knowledge actually grows. Not through blind acceptance, but through respectful disagreement. Through students who honor their teachers by taking their ideas seriously enough to challenge them. Lived during Ionia's intellectual and cultural golden age. Okay, so let's zoom out. What's happening in the Greek world around 586-525 BC? This is the archaic period of Greek history. The alphabet has been adopted from the Phoenicians. Writing is spreading. City-states are developing. Trade networks are expanding. And crucially, Greeks are encountering other civilizations, Egyptian mathematics, Babylonian astronomy, Persian religious ideas. And something remarkable happens when cultures collide. People start to question their own assumptions. When you meet someone who worships different gods, explains thunder differently, organizes society differently, you start to realize that your way isn't the only way. That maybe, just maybe, the stories you were told as a child aren't the final word on reality. This is the soil from which philosophy grows. Not isolation, but contact. Not certainty, but doubt. Not tradition alone, but tradition questioned. Now here's what we don't know about Anaximenes' life, and it's frustrating. We don't know if he traveled. We don't know if he had a family. We don't know what he looked like. what his personality was like, whether he was charismatic or shy, funny or serious. What we have are his ideas. And those ideas were powerful enough that people kept talking about them, kept writing about them, for centuries after his death. But to really understand why his ideas mattered, we need to understand the world he was reacting against. This slide is absolutely crucial, because what Anaximenes is doing doesn't happen in a vacuum. He's part of a massive shift in human consciousness, one of the most important transitions in intellectual history. Stage 1, mythological thinking. This is where humanity starts. And let's be clear, I'm not dismissing mythology. Myths are powerful, they're beautiful. They encode wisdom, but they explain natural phenomena through divine agency. Why does it thunder? Zeus is angry. Why did the crops fail? You didn't sacrifice properly to Demeter. Why did that person get sick? They offended Apollo. Why do we have seasons? Persephone has to spend part of the year in the underworld. These are great stories. They're psychologically rich. They give meaning to suffering. But notice what they do. They make nature personal. They make the universe operate according to the whims and emotions of divine beings. And here's the thing. This isn't stupid. This is actually a sophisticated way of making sense of a chaotic, frightening world. If the gods are angry, you can appease them. If you perform the right rituals, you can influence outcomes. It gives you a sense of control. Stage 2, the questioning stage. And this is where it gets interesting. This is where Anaximenes lives. This is the transitional moment. People are starting to ask, wait, are the gods really causing all this? Or is there something else going on? Some underlying pattern, some natural process? Now, this is a terrifying question to ask in a traditional society. Because if Zeus isn't causing thunder, if Poseidon isn't causing earthquakes, then what does that mean about the gods? What does that mean about the priests who claim to interpret divine will? What does that mean about the whole structure of religious authority? This is why the Milesian philosophers are so brave. They're not just proposing alternative theories, they're challenging the entire worldview of their society. They're saying, we're going to seek rational explanations. And notice, they're not atheists. Anaximenes still thinks air is divine. He's not rejecting the sacred, but he's changing where he looks for it. He's finding divinity in nature itself, not in anthropomorphic gods throwing lightning bolts. Stage 3, natural philosophy. This is the goal, the direction they're moving toward, proposing material causes. This is the revolutionary move. What if we can explain natural phenomena through natural processes? What if water evaporates because of heat, not because a god wills it? What if earthquakes happen because of physical forces in the earth, not because Poseidon is upset? And here's what I need you to understand. This shift from mythological thinking to natural philosophy, this is the foundation of everything. This is the foundation of science. This is the foundation of medicine. This is the foundation of technology. This is the foundation of the modern world. Because once you start looking for natural explanations, once you start believing that the universe operates according to regular, discoverable principles rather than divine whim, everything changes. You can predict things, you can test things, you can improve things. You're no longer at the mercy of capricious gods. You're in a universe that makes sense. Now, does this mean the Milesians got it right? Oh, hell no. Anaximenes thinks air becomes stone through condensation. He thinks the earth is a flat disk floating on air. He thinks stars are fiery exhalations stuck to a crystalline dome. But he's asking the right kind of questions. He's using the right kind of method. And that's what matters. Look at this progression on the slide again. Mythological thinking. Gods explain everything. Questioning stage. Maybe there are natural explanations. Natural philosophy. Systematic search for material causes. Anaximenes is right here in the middle. He's the bridge. He's got one foot still in the old world. Air is divine, it's eternal, it's alive. But he's got the other foot in the new world. Air transforms through observable processes, rarefaction and condensation, mechanisms we can understand. You know what this reminds me of? It reminds me of every major intellectual transition. When Darwin proposed evolution, he wasn't the first person to question the fixity of species. When Einstein proposed relativity, he wasn't the first to question Newtonian mechanics. There's always this messy middle period where old and new ideas coexist, where brilliant people are trying to break free from old paradigms but haven't quite gotten there yet. And we need to honor that. We need to honor the struggle. Because it's easy for us, 2,600 years later, with all our scientific knowledge, to look back and say, well, obviously air isn't the fundamental substance of reality, but put yourself in Anaximenes' sandals. You live in a world where most people think gods control everything. You're trying to find a natural explanation. You're trying to use reason and observation. And you come up with a theory that actually works for explaining a lot of phenomena, at least in a preliminary way. That takes genius. That takes courage. That takes intellectual honesty. So now that we understand the historical moment Anaximenes is operating in, this crucial transition from myth to reason, let's dive into his actual theory. Let's see what he proposed and why it was so brilliant even in its wrongness. All right, here we go. This is it, the main event. Anaximenes' big idea. Air. Air is the arch, the fundamental principle, the basic substance, the stuff that everything else is made of. And I can see some of you thinking, really, air? That's the big revolutionary idea? Air. But hold on. Let's break down what he actually means, because this is way more sophisticated than it sounds. Air as the fundamental substance of all reality. Okay, first question. Why air? Why not stick with Thales' water? Why not keep Anaximander's abstract apeiron? Here's Anaximenes' reasoning, and it's actually pretty clever. Air is everywhere. It surrounds us. It fills empty spaces. You can't see it most of the time, but you know it's there. You breathe it. You feel it as wind. It's more subtle than water, more pervasive than earth or fire. And here's the kicker. Air can change. You can feel warm air and cold air. You can see mist and clouds, which are clearly air in some transformed state. Air seems to be this incredibly versatile substance that can take different forms. Air is eternal and divinely animated. Now this is where it gets really interesting, because Anaximenes isn't proposing some dead, inert substance. He's not a materialist in the modern sense. For Anaximenes, air is divine. It's eternal. It has no beginning and no end. It's alive. It's animated. It has some kind of inherent vitality. And think about why this makes sense in his context. What's the Greek word for breath? Pneuma. What's the word for soul or spirit? Also pneuma. The same word. When you're alive, you breathe. When you die, you stop breathing. Your pneuma, your breath soul, leaves your body. So there's this deep connection in Greek thought between air, breath, life, and divinity. Anaximenes is tapping into something profound here. He's saying, look, what if that connection isn't just metaphorical? What if air really is the life principle? What if the stuff you breathe in and out is actually the same substance that makes up the entire cosmos? Air always in flux, never static. This is crucial. Air is always moving, even when you can't see it. Even when there's no wind, air is in motion. It's dynamic, not static. And this matters because one of the big problems in early Greek philosophy is explaining change. If reality is fundamentally one thing, how does anything ever change? How do we get diversity from unity? Anaximenes' answer. The fundamental substance itself is constantly in motion. Change isn't something that happens to reality from the outside. Change is built into the very nature of the arche, boundless and endless in its extent. Here's where Anaximenes is clearly influenced by his teacher Anaximander. Remember, Anaximander proposed the apeiron, the boundless, the infinite. Anaximenes keeps that idea of infinity, but he makes it concrete. Air is infinite. It extends forever. There's no edge to it, no boundary. It's not like there's a certain amount of air and then nothing. Air is the cosmic substance that fills all space, which, by the way, is wrong. We know there's a vacuum in space, but again, wrong answer, right kind of thinking. He's trying to solve the problem of what fills the void, what prevents absolute nothingness. Now, let me step back and tell you what I find most fascinating about this theory. Anaximenes is trying to solve multiple problems at once. 1. What's the basic substance of reality? Air. 2. How can one substance become many different things? Through transformation, which we'll get to in the next slide. 3. What's the relationship between matter and life? They're the same thing. Air is both physical substance and life principle. 4. What's the relationship between the human and the cosmic? We breathe the same air that constitutes the universe. We're literally made of the same stuff as the stars. Do you see how elegant this is? With one simple proposal, air as arch, he's providing a unified theory of physics, biology, psychology, and theology. Okay, so we've established that Anaximenes thinks air is the fundamental substance. But let's go deeper. What does he mean by air? Because it's not just the stuff you breathe. Connection to pneuma, life force, and respiration. I mentioned this before, but let's really dig into it. In ancient Greek thought, there's this profound connection between breath and life. You're born, you take your first breath, you die, you breathe your last. Breath is the marker of life itself, and it's not just humans. Animals breathe. Even plants, in a way, seem to breathe. They take in air, they release it. So breath seems to be the universal sign of living things. Now Anaximenes takes this observation and makes it cosmic. He says, what if the entire universe is alive in the same way we're alive? What if the cosmos itself breathes? There's actually a fragment, one of the few direct quotes we have from Anaximenes, where he says something like, just as our soul, being air, holds us together, so do breath and air encompass the whole cosmos. Think about that. Just as our soul, being air, holds us together, he's making an explicit parallel between the human microcosm and the cosmic macrocosm. We're not separate from the universe. We're miniature versions of it. The same principle that animates us animates everything. More than just atmosphere, the substance of reality. This is where we have to be careful not to impose our modern understanding of air onto Anaximenes. When we think of air, we think of the mixture of gases in Earth's atmosphere. Nitrogen, oxygen, carbon dioxide, trace elements. We think of something specific, something measurable, something with a chemical formula. That's not what Anaximenes means. For Anaximenes, air is a metaphysical principle. It's the underlying reality that can take different forms. It's not just the atmosphere. It's the substrate of everything. The earth beneath your feet, condensed air. The water you drink, condensed air. The fire that burns, rarefied air. The stars in the sky, rarefied air. So when we translate his word, which is air in Greek, as air, we're actually doing him a bit of a disservice. He's talking about something more fundamental, more primal. Maybe we should translate it as the aerial principle or the breath substance. But air is shorter, so we'll stick with it. Just remember, it's air with a capital A. Air as cosmic principle, not just the stuff you're breathing right now. Connects all things in nature through common substance. And here's where Anaximenes' theory becomes really powerful philosophically. One of the deepest questions in philosophy is, what makes the universe a universe? What makes it a unified whole rather than just a random collection of unrelated things? Anaximenes' answer is beautiful in its simplicity. Everything is connected because everything is made of the same stuff. You, me, the chair you're sitting on, the air you're breathing, the stars above, we're all transformations of the same fundamental substance. This means there's a deep unity to reality. It means that when you study one part of nature, you're learning about the whole. It means that the laws governing the heavens are the same laws governing the earth, which, by the way, is a principle that won't be fully established until Newton 2,000 years later. But there's also something almost spiritual about this idea. If everything is made of the same divine air, then everything is connected. You're not separate from nature, you're part of it. Every breath you take is an exchange with the cosmos. You're literally breathing in the universe and breathing out yourself. Which is a much more poetic way of thinking about respiration than I'm exchanging oxygen and carbon dioxide with my environment. Now here's what I want you to notice about these three aspects of air in Anaximenes' philosophy. Breath of life. This is the biological experiential aspect. Air as something we directly experience. Cosmic principle. This is the metaphysical aspect. Air as ultimate reality. Unifying element. This is the logical, systematic aspect. Air as the explanation for unity in diversity. Anaximenes is doing what all great philosophers do. He's taking something familiar, breath, wind, air, and showing us that it's actually far more profound than we realized. He's revealing the extraordinary in the ordinary. But here's the question that should be nagging at you right now. Okay, fine. Everything is air. But how? How does air become water? How does air become earth? How does air become fire? Because if Anaximenes can't answer that question, his theory is just hand-waving. It's just saying it's all air without explaining anything. But here's the brilliant part. He does have an answer. And it's an answer that introduces one of the most important concepts in all of natural philosophy. The idea of transformation through quantitative change. And that's where we're going next. Because Anaximenes doesn't just say air becomes everything. He tells us how. He gives us a mechanism. He gives us rarefaction and condensation. And when you understand this mechanism, you're going to see why Anaximenes isn't just proposing a theory. He's laying the groundwork for chemistry, for physics, for the entire scientific understanding of matter. This is where it gets really good. All right. This is where Anaximenes earns his place in the history of philosophy. This is the game changer. Because remember what I said, it's not enough to just declare everything is air. You need to explain how air becomes everything else. And Anaximenes gives us a mechanism. Two processes, actually. Rarefaction and condensation. Look at this beautiful, elegant progression. Air is in the middle, the neutral state, and from there it can go in two directions. Rarefaction. Air thins out, becomes less dense, spreads apart, and it becomes fire. Condensation. Air compresses, becomes more dense, packs together, and it becomes wind, then clouds, then water, then earth, then stones. Do you understand what he just did? He explained qualitative change, different substances with different properties through quantitative change, differences in density and compression. This is huge. This is one of the most important ideas in the history of science. The idea that what looks like a fundamental difference in kind is actually just a difference in degree. Think about what this means. Water doesn't have some special waterness that makes it fundamentally different from air. It's just air that's been compressed. Earth isn't some totally different substance. It's just really compressed air. Fire isn't a separate element. It's just really rarefied air. Now, is this literally true? No. We know that water is H2O, that earth is made of various minerals, that fire is a chemical reaction. Anaximenes got the details wrong. But the principle? The principle is profound. Because what Anaximenes discovered, or at least intuited, is that apparent diversity can emerge from underlying unity through transformation. That's the foundation of chemistry. That's the foundation of physics. That's how we understand phase transitions. Ice to water to steam. That's how we understand states of matter. You know what Anaximenes would have loved? A pressure cooker. Because that's literally his theory in action. You increase pressure. You change the properties of the substance. He would have been like, "See? I told you." Let me break down why this mechanism is so clever. First, it's observable. You can actually see air condensing into mist, into clouds. You can see water evaporating. You can feel warm air rising, rarefaction, and cold air sinking, condensation. This isn't pure speculation. It's based on real phenomena. Second, it's reversible. The process can go both ways. Air can condense into water, and water can evaporate back into air. This explains the cycles we see in nature, the water cycle, seasonal changes, the constant flux of the natural world. Third, it's continuous. Notice the progression. Air, wind, clouds, water, earth, stones. It's not like air suddenly jumps to being water. There are intermediate stages. It's a gradual transformation. And here's what I find absolutely fascinating. Anaximenes is proposing that motion and density are the fundamental properties that explain everything else. Color? That's just how light interacts with air at different densities. Temperature? That's related to how compressed or rarefied the air is. Texture? Hardness? Softness? All just different degrees of compression. Now you might be thinking, "But Professor, this is obviously wrong. I mean, a rock isn't just compressed air, that's ridiculous." And you're right. It is wrong, literally. But ask yourself this. Is it ridiculous? Because what Anaximenes is doing is trying to reduce the complexity of nature to simple, understandable principles. And that's exactly what science does. We're still trying to do the same thing. We're just using different concepts. Modern physics says everything is made of quarks and leptons in different configurations. That's not so different from saying everything is made of air in different densities. We've just gotten more precise about what the fundamental stuff is and what the mechanisms of transformation are. But here's what Anaximenes got profoundly right. Change is real, and it follows natural laws. Things don't transform randomly or by divine whim. There's a process, a mechanism, a reason why air becomes water and water becomes earth. Okay, so we've got the fundamental substance, air. We've got the mechanism of change, rarefaction, and condensation. Now let's see what Anaximenes does with this theory. Let's see how he explains the cosmos itself. And I'm going to warn you right now, this is where things get interesting, because some of this is going to sound absolutely bonkers to modern ears. But stay with me, because even the bonkers parts are instructive. Earth conceived as a flat disk floating on air. Yep, flat Earth. Anaximenes thinks the Earth is a flat disk, like a giant plate floating on air. Now, before you laugh too hard, remember, this is 2,600 years ago. There are no satellites, no space travel, no way to get high enough to see the curvature of the Earth, and from ground level, the Earth does look flat. But here's what's interesting. Anaximenes isn't just making this up randomly. He's trying to solve a real problem. What holds the Earth up? If you're standing on the ground, you might wonder, what's beneath this? What's holding it up? If I dig down far enough, what do I hit? Thales said the Earth floats on water, which raises the question, what holds the water up? Anaximenes says, no, the Earth floats on air, and since air is infinite and extends everywhere, you don't need something to hold the air up. Problem solved. Except, of course, the Earth doesn't float on air. It's a sphere held in orbit by gravity. But again, he's asking the right question. What prevents the Earth from falling? He just doesn't have the conceptual tools to arrive at the right answer. Stars as fiery exhalations fixed to a crystalline dome. Okay, this is wild. Anaximenes thinks the stars are made of fire, which makes sense, right? They look bright and hot. And fire, in his theory, is rarefied air. So the stars are air that's been rarefied to the point of becoming fiery. But how do they stay up there? How do they move? His answer? They're fixed to a crystalline dome that rotates around the Earth. Basically, he's imagining the sky as a giant snow globe, and we're inside it, and the stars are like little lights stuck to the inside of the dome. Now, this is completely wrong. But notice what he's doing. He's trying to explain regular, predictable motion. The stars move in patterns. They rise and set at predictable times. There's order to their movement, so he proposes a mechanism. They're attached to something solid that rotates. It's a mechanical explanation for celestial motion. And that impulse, to explain celestial phenomena through mechanical principles rather than divine intervention, that's the birth of astronomy as a science. Heavenly bodies revolving around Earth on currents of air. But wait, there's more. Because Anaximenes also thinks that the celestial bodies, sun, moon, planets, move on currents of air. Think about it from his perspective. Air is always in motion. Air creates wind. What if there are massive currents of air in the upper atmosphere that carry the celestial bodies around? It's like he's imagining cosmic rivers of air flowing in circles around the Earth, and the sun and moon are like boats floating on these rivers. Again, completely wrong. But the underlying insight, that motion might be explained by invisible forces, by currents and flows we can't directly see, that's actually pretty sophisticated. Now let me step back and talk about what Anaximenes' cosmology tells us about his overall project. 1. He's committed to naturalistic explanation. He's not saying, the gods hold up the earth, or Zeus moves the sun across the sky. He's proposing physical mechanisms. 2. He's trying to create a unified theory. The same substance that makes up the earth also makes up the stars. The same processes that create water also create fire. Everything fits into one coherent system. 3. He's geocentric. Earth is at the center, which makes sense from his observational standpoint. The sun and stars appear to revolve around us. Turns out we're not the center of the universe. That was a bit of human arrogance. But you can't blame him for going with the obvious interpretation of what he could observe. Here's what I want you to appreciate about this cosmology, even though it's wrong in almost every detail. Anaximenes looked up at the night sky, the same sky humans had been looking at for tens of thousands of years. And instead of seeing the dwelling place of gods, instead of seeing divine mysteries beyond human comprehension, he saw a system that operates according to principles, a system that can be understood. That shift from the heavens are the realm of the gods to the heavens are part of nature and follow natural laws, that's revolutionary. That's the beginning of cosmology as a science. And yes, his specific model is wrong. The Earth isn't flat. The stars aren't on a dome. The sun doesn't float on air currents. But the method, observe the phenomena, propose natural mechanisms, build a coherent system, that method is right. And that method eventually leads to Copernicus, to Galileo, to Newton, to Einstein, to our modern understanding of the cosmos. Anaximenes is like the first person trying to build an airplane. His design doesn't work. It can't actually fly. But he's figured out that flight is possible, that it can be achieved through natural principles, that it's not just magic or divine intervention. And that insight, that the natural world is comprehensible, that we can figure it out, that's the foundation of everything that comes after. Now, Anaximenes doesn't just apply his theory to the grand cosmic scale, he also uses it to explain everyday phenomena, weather, earthquakes, rainbows. And some of these explanations are actually pretty clever. Alright, now we get to see Anaximenes' theory in action. Because it's one thing to propose that everything is air transforming through rarefaction and condensation. It's another thing to actually use that theory to explain specific phenomena, and this is where Anaximenes really shines. He takes his abstract principle and applies it to the weather, to things people experience every single day. Clouds, rain, hail, snow. Let's see how he explains them. Clouds. Air condensed to visible form. Okay. Think about this from Anaximenes' perspective. You're looking up at the sky. Sometimes it's clear blue. Sometimes there are these white, fluffy things floating around. What are clouds? His answer, they're air that's been condensed just enough to become visible. The air is still air. It's not water yet, but it's compressed enough that you can see it. And you know what? He's basically right. I mean, he doesn't understand the molecular process. He doesn't know about water vapor and condensation nuclei, but the core insight is correct. Clouds are water in a transitional state between invisible vapor and liquid. Clouds are literally air becoming water. They're the intermediate stage in his progression. Air, clouds, water. He nailed it. Rain, further condensed clouds releasing water. So if clouds are condensed air, what happens when they condense even more? They become water. And that water is heavy, so it falls. Rain. Again, this is remarkably accurate as a basic explanation. He's observing that rain comes from clouds, and he's explaining it through his mechanism of condensation. The air in the clouds compresses further, becomes liquid, and gravity pulls it down. Now, he doesn't understand evaporation and the water cycle in the modern sense. He doesn't know about temperature and pressure gradients. But the fundamental idea that rain is condensed atmospheric moisture, that's solid. Hail, snow, water further frozen in clouds. Okay, this is where it gets trickier. Because now we're not just talking about condensation, we're talking about freezing, and Anaximenes needs to explain why sometimes rain falls as liquid, sometimes as ice. His explanation, if the water in the clouds gets condensed even more, and if it's cold enough up there, it freezes. Hail and snow are just water that's been compressed and cooled to the point of becoming solid. Now the physics here is a bit wonky. Freezing isn't really about compression in the way he's thinking. It's about temperature and the arrangement of molecules. But again, he's observing a real phenomenon and trying to fit it into his theoretical framework. And here's what I love about this. Anaximenes is doing science. He's taking his general theory, rarefaction and condensation, and he's making predictions about specific cases. Air condenses. Clouds. Check. Clouds condense more. Rain. Check. Rain condenses and cools more. Hail and snow. Well, sort of. This is the scientific method in embryonic form. You have a theory. You apply it to specific cases. You see if it matches observation. And if it doesn't quite work, you refine it. Now, let me tell you what's really remarkable about these meteorological explanations. They're naturalistic. Remember, in Anaximenes' time, most people would explain weather through divine action. Zeus sends the rain. The gods send storms as punishment. Drought means you've angered the deities. But Anaximenes says, No. Rain isn't Zeus crying or being generous. Rain is a natural process. It's air condensing through mechanical principles. It's predictable, it's regular, it's part of the natural order. That's a radical claim. That's saying the weather isn't controlled by divine whim, it's controlled by natural law, which, by the way, is why you can have meteorology as a science. If weather were truly random or controlled by capricious gods, you couldn't predict it. But if it follows natural principles, even if you don't fully understand those principles yet, then you can start to make forecasts. And Anaximenes doesn't stop with weather. He applies his theory to even more dramatic natural phenomena. Alright, we've talked about how Anaximenes influenced individual philosophers, but now I want to zoom out even further and talk about something bigger. How did Anaximenes contribute to the development of science itself? Because what we're looking at here isn't just the history of philosophy, it's the history of how humans learn to investigate the natural world systematically. And Anaximenes plays a crucial role in that story, encouraging explanation without supernatural intervention. Okay, I've mentioned this before, but I want to really hammer it home because it's that important. Before the Milesians, before Thales, Anaximander, and Anaximenes, the default explanation for natural phenomena was divine action. Thunder, Zeus, earthquakes, Poseidon, disease, you angered Apollo, drought, the gods are punishing you. And here's the thing, that's not a stupid worldview. It's actually psychologically sophisticated. It gives meaning to suffering. It provides a sense of control. If you perform the right rituals, maybe you can influence the gods. It creates social cohesion through shared religious practices. But, and this is crucial, it's a dead end for scientific inquiry. Because if Zeus causes thunder, what more is there to say? You can't investigate Zeus. You can't run experiments on divine will. You can't predict when Zeus will be angry, you're stuck, knowledge can't advance. But Anaximenes says, what if we don't invoke the gods? What if we look for natural causes? What if thunder and lightning have physical explanations? And suddenly, the door to scientific inquiry swings open. Because natural causes can be investigated. They can be tested. They can be understood. This is the foundation of everything. This is why we have medicine instead of just prayer. This is why we have meteorology instead of just sacrifice. This is why we have seismology instead of just appeasing Poseidon. Anaximenes didn't get all his natural explanations right. We've established that. But he established the principle. Look for natural causes first. Don't jump to supernatural explanations. Assume the universe operates according to regular, discoverable principles. And that principle, that simple revolutionary principle, is the bedrock of science, seeking common principles behind diverse phenomena. Now, here's another crucial contribution. Anaximenes doesn't just explain individual phenomena in isolation. He's looking for unity. He's looking for common principles that explain everything. Think about what he's doing. He proposes that air is the fundamental substance. Then he uses rarefaction and condensation to explain clouds, rain, snow, earth, fire, wind, earthquakes, lightning, everything. One substance, one mechanism, multiple phenomena. This is the drive toward theoretical unification, and it's one of the most powerful impulses in science. Newton unified celestial mechanics and terrestrial mechanics. Same laws govern the heavens and the earth. Maxwell unified electricity and magnetism. They're aspects of the same electromagnetic force. Einstein unified space and time. They're aspects of the same space-time continuum. The whole history of physics is a quest for unification, for finding the simple principles that explain diverse phenomena, for showing that what looks like many different things is actually one thing in different forms. And Anaximenes is doing this 2,600 years ago. He's pioneering the search for unified theories. Now his specific unification doesn't work. Everything isn't actually air in different densities. But the method, the drive to find common principles, to reduce complexity to simplicity, to unify our understanding, that's exactly right. Establishing foundation for physical sciences. All right, here's another way Anaximenes contributes to science. He's committed to materialism, not in the ethical sense, but in the philosophical sense. Materialism, philosophically, is the view that reality is fundamentally physical, that everything can be explained in terms of matter and its properties. that you don't need to invoke non-physical substances like souls or spirits or forms to explain the natural world. Now, Anaximenes isn't a pure materialist in the modern sense. Remember, he thinks air is divine and alive, but he's moving in that direction. He's saying that physical substance and physical processes can explain natural phenomena, and this is crucial for the development of the physical sciences. Because physics, chemistry, biology, they all assume that material processes can explain natural phenomena. They assume you can understand the world by studying matter and energy and their interactions. Anaximenes doesn't have our modern concept of matter. He doesn't know about atoms and molecules. He doesn't know about chemical bonds and nuclear forces. But he establishes the framework. Natural phenomena can be explained by the properties and transformations of physical substances. That's the foundation of all the physical sciences. Developing coherent framework for natural philosophy. And finally, and this might be the most important contribution, Anaximenes develops a systematic approach to understanding nature. He doesn't just make random observations. He doesn't just propose isolated explanations. He builds a system, a coherent framework where everything connects. What's the fundamental substance? Air. How does it transform? Rarefaction and condensation. What does this explain? Weather, earthquakes, celestial phenomena, everything. How do we know? Observation and experimentation. It all fits together. It's a system. And that's what science needs. Not just isolated facts, but coherent theoretical frameworks that organize our knowledge and guide further investigation. Now let me connect all four of these contributions. Natural causation. Science assumes natural explanations. Unified theory. Science seeks common principles. Material basis. Science studies physical processes. Systematic approach. Science builds coherent frameworks. These aren't just Anaximenes' contributions. These are the foundations of scientific thinking itself. And here's what I need you to understand. Science didn't just appear fully formed. It wasn't inevitable. It required people like Anaximenes to make these conceptual breakthroughs, to establish these principles, to show that this way of investigating the world works. Without the Milesians, without Thales, Anaximander, and Anaximenes, Western science might never have developed, or it might have developed much later, or in a different form. These guys are the pioneers. They're hacking through the jungle of human ignorance, establishing the trail that everyone else will follow. Okay, so we've established Anaximenes' contributions to the development of science broadly, but let's get more specific. How did ancient Greek thinkers themselves view Anaximenes? What did they say about him? Because remember, we don't have Anaximenes' own writings. What we have are references to him by later authors. So let's look at what they said. Aristotle praised Anaximenes for his more scientific approach to cosmology. Aristotle, writing in the 4th century BC, about 200 years after Anaximenes, is one of our main sources for pre-Socratic philosophy. And Aristotle is generally pretty critical. He's not shy about pointing out where earlier philosophers went wrong. But when it comes to Anaximenes, Aristotle is actually complimentary. He says Anaximenes' approach is more scientific, more rigorous than some of his predecessors. Why? Because Anaximenes provides a mechanism. He doesn't just say everything is air. He explains how air becomes other things. Rarefaction and condensation give you a process, a method of transformation. Aristotle appreciates this because Aristotle himself is all about explaining causes. He wants to know not just what things are, but why they are and how they change. And Anaximenes, by proposing rarefaction and condensation, is providing what Aristotle would call an efficient cause, a mechanism that explains how change happens. So even though Aristotle doesn't accept Anaximenes' specific theory, Aristotle has his own four-element system, he respects the approach. He sees Anaximenes as moving philosophy in a more scientific direction. Theophrastus preserved his ideas in early philosophical histories. Now, Theophrastus is Aristotle's student and successor, and Theophrastus wrote a massive work called Opinions of the Natural Philosophers, basically a history of pre-Socratic thought. Unfortunately, this work is mostly lost. We only have fragments and references to it in later authors, but what we do have shows that Theophrastus took Anaximenes seriously. Theophrastus preserved Anaximenes' ideas, transmitted them to later generations, included him in the canonical history of Greek philosophy. And this matters because this is how ideas survive. Without Theophrastus and other doxographers, writers who record the opinions of philosophers, we wouldn't know anything about Anaximenes. His own writings are lost. What we have is what later authors chose to preserve. And the fact that they did choose to preserve Anaximenes' ideas, that they thought he was important enough to include in the history of philosophy, tells us that ancient thinkers recognized his significance. Both Stoic and Epicurean schools incorporated aspects of Anaximenes' material theories into their physics. Okay, now we're jumping forward to the Hellenistic period, 3rd century BC and later. And we've got two major philosophical schools, the Stoics and the Epicureans. These are very different schools. The Stoics believe in divine providence and cosmic reason. The Epicureans are materialists who deny divine intervention. They disagree about almost everything, but both of them incorporate ideas from Anaximenes. The Stoics pick up on Anaximenes' idea that air, or pneuma, breath, is the life principle. They develop a sophisticated theory where pneuma is the active principle that organizes matter and gives life to living things. So Anaximenes' connection between air and life, between breath and soul, gets developed into a full-fledged Stoic physics. The Epicureans, on the other hand, are atomists. They follow Democritus in saying that reality is made of atoms and void. But even they acknowledge that Anaximenes was onto something with his material explanations of natural phenomena. They don't accept his specific theory. They think atoms, not air, are fundamental, but they respect his method of giving physical explanations for natural events. And this is fascinating to me, because it shows that Anaximenes' influence transcends particular philosophical schools. Both Stoics and Epicureans, who agree on almost nothing, find something valuable in his work. What does that tell you? It tells you that Anaximenes identified something fundamental, some insight that different philosophical traditions can build on, even if they take it in different directions. Now let me pull all this together and show you what Anaximenes' legacy in ancient Greek thought looks like. Aristotle praises his scientific approach and mechanism of change. Theophrastus preserves his ideas for future generations. Stoics develop his connection between air, pneuma, and life. Epicureans respect his material explanations of phenomena. This is a thinker who mattered. This is someone whose ideas were taken seriously for centuries. This is a philosopher who shaped the development of Greek thought in lasting ways. And remember, we're talking about a guy who lived in the 6th century BC. His ideas are still being discussed, debated, and incorporated into new systems 300, 400, 500 years later. How many of us can hope to have our ideas still relevant 5 centuries after we're gone? But here's what I find most remarkable about Anaximenes' legacy. It's not that later thinkers agreed with him. Most of them didn't. They rejected his specific theory that everything is air. But they engaged with him. They took his ideas seriously enough to argue with them, to build on them, to incorporate elements into their own systems. And that's the mark of a truly important thinker. Not that everyone agrees with you, but that everyone has to reckon with you. That your ideas become part of the conversation that can't be ignored. Anaximenes achieved that. He became part of the canonical history of Greek philosophy. His name appears in every ancient history of natural philosophy. His ideas get transmitted, debated, refined, criticized, and incorporated for centuries. And even when his specific theories were abandoned, when people stopped thinking everything was air, his approach survived. His commitment to natural explanation, his search for unified theories, his material basis for understanding reality, his systematic framework, those things didn't die with him. They became part of the foundation of Western thought. But here's the question we need to ask now. How does Anaximenes compare to his fellow Milesians? How does he stack up against Thales and Anaximander? What makes his contribution unique? And that's what we need to look at next. Alright, we've been talking about Anaximenes for a while now, and I've mentioned Thales and Anaximander along the way, but now I want to do a direct comparison. Let's put these 3 Milesians side by side and see what makes each one unique. Because this isn't just about cataloging different theories. This is about understanding how philosophical thought develops. How each generation builds on and critiques the previous one. Look at this progression. 3 philosophers, 3 different answers to the same question. What is the arche, the fundamental substance of reality? Thales. Water. Thales is the pioneer, the founder. He's the first person in the Western tradition to ask, what is the basic stuff of reality? And his answer is water. And as I mentioned before, this isn't a bad guess. Water is everywhere. It's essential for life. It can exist in different states: liquid, solid ice, gaseous steam. It seems to be involved in growth and change. But here's what Thales doesn't give us: a mechanism. He says everything is water, but he doesn't really explain how water becomes other things. How does water become earth? How does it become fire? His innovation is identifying one fundamental substance. That's huge. That's the beginning of material monism, but the theory is incomplete. Anaximander, apeiron, the boundless. Now, Anaximander is Thales' student, and he looks at his teacher's theory and says, wait, there's a problem here. If everything is water, then water is the fundamental reality. But water is a specific thing. It has specific properties. It's wet, it's cold, it flows. But how can something specific and limited be the source of everything? How can water, which is itself one particular substance, give rise to its opposite, fire? So Anaximander makes a brilliant philosophical move. He says the fundamental substance can't be anything we can directly observe. It has to be something more abstract, more indefinite. He calls it the apeiron, the boundless, the infinite, the indefinite. It's not water or air or earth or fire. It's something prior to all of these, something from which they all emerge. This is sophisticated metaphysical thinking. Anaximander is saying that ultimate reality might be something we can't directly perceive, that it might be more fundamental than anything in our experience. It's almost like he's anticipating modern physics, where the fundamental stuff of reality, quantum fields, strings, whatever, isn't anything we can directly observe or intuitively grasp. But, and here's the problem, the apeiron is so abstract that it's hard to work with. How does the apeiron become specific things? What's the mechanism? Anaximander has some ideas about opposites separating out, but it's vague. Anaximenes, air. And this is where Anaximenes comes in. He looks at both his predecessors and says, I think we need something in between. Thales is too specific. Water can't really explain everything. Anaximander is too abstract. The apeiron is hard to observe and work with, so Anaximenes chooses air. And here's why this is brilliant. 1. Air is observable. You can feel it, breathe it, see its effects. It's not as abstract as the apeiron. 2. But air is also subtle and pervasive. It's not as limited and specific as water. It fills all space. It's everywhere. 3. And most importantly, Anaximenes gives us a mechanism. Rarefaction and condensation explain how air becomes everything else. Do you see what he's doing? He's synthesizing the insights of his predecessors while correcting their weaknesses. Now look at the third column, key innovation. Thales. First material principle. The innovation is asking the question and proposing one fundamental substance. Anaximander. Abstract principle. The innovation is recognizing that the fundamental reality might not be anything we directly observe. Anaximenes. Mechanism of change. The innovation is explaining how transformation happens through rarefaction and condensation, so we have a progression. Thales asks the question and proposes material monism. Anaximander makes it more philosophically sophisticated by abstracting from observable substances. Anaximenes makes it more scientifically rigorous by providing a mechanism. This is dialectical development. This is how knowledge advances. Not through one genius getting everything right, but through a conversation across generations where each thinker builds on and critiques the previous one. And here's what I want you to notice. Each of these innovations is valuable. Each one contributes something important to the development of philosophy and science. From Thales, we get the idea that reality has a fundamental unity, that we should look for one principle underlying diversity. From Anaximander, we get the idea that ultimate reality might transcend our direct experience, that we need abstract theoretical concepts. From Anaximenes, we get the idea that we need mechanisms, that we need to explain how transformations occur. And all three of these insights are still part of science today. Unity. We're still looking for unified theories, grand unified theory, theory of everything. Abstraction. Our fundamental physics involves entities we can't directly observe. Quarks, quantum fields, dark matter. Mechanisms. We demand explanations of how things work. Chemical reactions, evolutionary processes, physical forces. The Milesians got the specific answers wrong, but they established the framework for asking the right questions. How have modern thinkers rediscovered and reinterpreted Anaximenes over the centuries? Because Anaximenes' ideas didn't just survive in an unbroken chain from ancient times to now. They were lost, rediscovered, reinterpreted, seen through different lenses in different eras. Renaissance. Revival of interest in pre-Socratic thought as classical texts rediscovered. Okay, so during the Middle Ages in Europe, knowledge of pre-Socratic philosophy was pretty limited. Most of what survived was filtered through Aristotle and later commentators. The original texts were lost, but then comes the Renaissance, 14th, 15th, 16th centuries. And there's this massive project of recovering ancient texts. Scholars are hunting through monastery libraries, getting manuscripts from Byzantium, translating Greek texts into Latin, and as they're doing this, they're rediscovering the pre-Socratics. They're reading Diogenes Laertius, reading the doxographers, piecing together what Anaximenes and the other early philosophers actually said. Now, the Renaissance scholars are reading Anaximenes through their own concerns. They're interested in natural philosophy, in alternatives to Aristotelian scholasticism, in the origins of scientific thinking. So they see Anaximenes as a pioneer of natural science, as someone who broke free from mythological thinking and tried to explain nature through natural causes, which is true. But it's also a Renaissance interpretation. They're reading him as a proto-scientist because they're interested in developing new sciences. 19th century scholarly analysis by Hegel, Nietzsche, and others examining philosophical foundations. Now we jump to the 19th century, and you've got major philosophers taking the pre-Socratics seriously as philosophers, not just as primitive scientists. Hegel writes about the pre-Socratics in his lectures on the history of philosophy, and Hegel sees them as the beginning of the dialectical development of thought. He sees Anaximenes as part of the progression from Thales to Anaximander to Anaximenes, thesis, antithesis, synthesis. Hegel loves this stuff because it fits his model of how ideas develop through contradiction and resolution. Nietzsche writes a whole book, Philosophy in the Tragic Age of the Greeks, about the pre-Socratics. And Nietzsche is fascinated by them because he sees them as bold, creative thinkers who weren't yet constrained by Socratic rationalism. Nietzsche loves that Anaximenes just asserts that everything is air. He doesn't get bogged down in endless argumentation. He has a vision and he proclaims it. Now Nietzsche's reading is very much shaped by his own philosophical project, his critique of Socratic rationalism, his celebration of pre-Socratic boldness. But it's a serious engagement with Anaximenes as a thinker, not just a historical curiosity. And throughout the 19th century, you've got serious scholarly work on the pre-Socratics. People are collecting fragments, analyzing sources, trying to reconstruct what these early philosophers actually said and meant. This is when pre-Socratic philosophy becomes an academic field of study. When people start writing dissertations on Anaximenes, publishing critical editions, debating interpretations, 20th century, connection to history of science and early materialist theories. In the 20th century, the focus shifts somewhat. Now, scholars are interested in Anaximenes as part of the history of science. You've got historians of science like George Sarton, Charles Singer, others, who are tracing the origins of scientific thinking. And they see the Milesians, including Anaximenes, as crucial figures in the development of rational empirical inquiry. They're asking questions like, how did science emerge? What were the preconditions for scientific thinking? What was the transition from mythological to rational explanation? And Anaximenes becomes a case study. He's an example of early materialist thinking, early attempts at systematic observation, early efforts to find natural explanations. There's also interest in Anaximenes from philosophers of science. People like Karl Popper are thinking about what makes theories scientific, what makes them testable and falsifiable. In Anaximenes' theory, everything is air transforming through rarefaction and condensation. That's actually a pretty good example of a testable theory. It makes predictions. You can check whether it matches observations. It fails those tests, but it's the right kind of theory. It's empirical. It's systematic. It's falsifiable. Present day, continued relevance in philosophy of science and metaphysics. And today, Anaximenes is still being studied, still being reinterpreted, still being taught in philosophy departments around the world. Philosophy of science. People study Anaximenes when they're thinking about theory construction, about how scientific explanations work, about the role of mechanisms in science. Metaphysics. People study Anaximenes when they're thinking about substance, about change, about the relationship between unity and diversity. History of philosophy. People study Anaximenes to understand the origins of Western philosophy, to see how philosophical traditions develop. And here's what's remarkable. Every generation finds something new in Anaximenes. Every era reads him through its own concerns and discovers new insights. The Renaissance saw him as a proto-scientist breaking free from mythology. The 19th century saw him as part of the dialectical development of thought. The 20th century saw him as a pioneer in the history of science. The 21st century sees him as relevant to debates about emergence, reduction, and the nature of scientific explanation. And this is what happens with truly important thinkers. They're not just fixed historical artifacts, they're living parts of ongoing conversations. Each generation brings new questions, new concerns, new interpretive frameworks, and discovers new dimensions of their thought. Now let me pull together this whole story of rediscovery and reinterpretation. Anaximenes' ideas were preserved in ancient sources. They were partially lost during the Middle Ages. They were rediscovered in the Renaissance. They were seriously analyzed in the 19th century. They were connected to the history of science in the 20th century. And they remain relevant to contemporary philosophy today. That's a 2,600-year journey, from ancient Miletus to modern philosophy departments. And at every stage, people have found something valuable, something worth engaging with, something that illuminates their own concerns. This is what intellectual immortality looks like. Not that everyone agrees with you, they don't. Not that your specific theories survive, they don't. But that your questions endure, that your methods influence future inquiry, that your ideas remain part of the conversation. Anaximenes achieved that. He's been dead for 2,500 years, but we're still talking about him, still finding value in his thought, still learning from both his insights and his mistakes. How many of us can hope for that kind of legacy? But now we need to step back and look at the really big picture. We need to see where Anaximenes fits in the grand sweep of intellectual history. We need to understand his place in the story of how humans learn to think. Alright, we're coming to the home stretch here, and I want to zoom way out and show you the really big picture, because Anaximenes isn't just one philosopher among many. He occupies a crucial position in the entire history of human thought. Look at this diagram. This is the story of how humanity learned to think about the world. And Anaximenes is right there at a pivotal moment. Stage 1. Mythological thinking. Gods and supernatural forces explain natural phenomena. This is where we start. For tens of thousands of years, maybe hundreds of thousands, humans explain the world through stories, through gods, through supernatural forces. Why does the sun rise? A god pulls it across the sky. Why does it rain? The sky god is crying, or blessing the earth, or angry. Why do people get sick? Demons, curses, divine punishment. Why do we die? The gods have decided our time is up. And this isn't primitive in some dismissive sense. This is actually sophisticated meaning-making. These stories explain not just what happens, but why it matters. They connect natural events to moral and spiritual significance. But here's the limitation. If gods control everything, if divine will is the explanation, then there's a ceiling on what you can understand. You can't investigate the gods, you can't predict their actions, you can't control natural forces, you're at their mercy. Stage 2. Anaximenes. The bridge. Rational explanation while retaining unifying principle. And this is where Anaximenes comes in. Right here. At this hinge point in human history. Because Anaximenes is doing something absolutely remarkable. He's keeping one foot in the old world while stepping into the new. Old world. Air is divine. It's eternal. It's alive. It has some sacred quality. New world. Air transforms through natural processes, rarefaction and condensation. These are mechanical explanations, not divine interventions. Do you see how brilliant this is? How necessary this transitional moment is? You can't just jump from God's control everything to purely mechanical natural laws overnight. That's too big a leap. People need a bridge, and Anaximenes is that bridge. He says, yes, there's something divine about reality. But that divine element operates through regular, understandable processes. We can investigate it. We can comprehend it. He's secularizing explanation while keeping the sacred. He's naturalizing the divine. He's making the cosmos both meaningful and comprehensible. That's a delicate balance, and it's exactly what that historical moment needed. Stage 3. Scientific materialism. Physical explanations without supernatural elements. And once Anaximenes opens that door, others walk through it further. The atomists, Leucippus and Democritus, propose a fully mechanical universe. Atoms and void, nothing else. No divine principle needed. Later you get Epicurus, who explicitly denies divine intervention in natural events. The gods exist, he says, but they don't care about us. Nature operates according to its own laws, and this leads eventually to modern scientific materialism, the view that natural phenomena can be fully explained through physical processes, no supernatural intervention required. Now we can debate whether that's the right worldview. That's a philosophical question. But historically, that's the direction things move. From mythological to transitional to naturalistic explanation. Stage 4. Modern science. Empirical, mathematical, and experimental approaches. And this brings us to modern science, which takes the naturalistic approach and adds empiricism, systematic observation and experimentation, mathematics, quantitative description and prediction, instrumentation, tools that extend our senses, peer review, collective verification of claims, falsifiability, theories that can be tested and potentially disproven. This is the full flowering of the seed that Anaximenes planted, the idea that we can understand nature through reason and observation. Now here's what I want you to see. This progression isn't inevitable. It's not like humanity was always destined to develop science. It required specific people, at specific times making specific choices. It required intellectual courage. It required people willing to question tradition, to challenge authority, to think differently. And Anaximenes was one of those people. At a crucial moment, he made a choice. I'm going to look for natural explanations. I'm going to use observation and reason. I'm going to propose testable theories. That choice, multiplied across many thinkers over many generations, that's how we got science. That's how we got the modern world. So when you look at this diagram, mythological thinking, Anaximenes the bridge, scientific materialism, modern science, you're seeing the story of human intellectual development. And Anaximenes is right there at the crucial transition. Not at the beginning, not at the end, but at the hinge point where everything changes. That's why he matters. Not because he got all the answers right, he didn't, but because he helped humanity turn a corner. He helped us move from one way of thinking to another. And every time you use science, every time you trust a weather forecast, take medicine, use technology, you're benefiting from that turn. You're living in the world that Anaximenes helped create. All right, we've covered a lot of ground. We've talked about Anaximenes' life, his theory, his method, his influence, his limitations, his enduring questions, his place in history. Now let's bring it all together. Let's talk about the lasting impact of this remarkable thinker. This is what Anaximenes is, fundamentally. He's a pioneer. He's someone who goes first, who makes the path, who shows that a new way of thinking is possible. Before Anaximenes, natural explanation was rare, tentative, uncertain. After Anaximenes and his fellow Milesians, it becomes a tradition. It becomes something that later thinkers can build on, refine, develop. He's a champion of the idea that we can understand the world, that nature operates according to principles we can discover, that we're not helpless before incomprehensible forces. That's a revolutionary stance. And he championed it at a time when it was far from obvious, far from accepted. 2,500 plus years of influence. Continued relevance in philosophy of science. 2,500 years. That's how long Anaximenes has been part of the intellectual conversation. Ancient Greeks studied him. Romans read about him. Medieval scholars preserved his ideas. Renaissance thinkers rediscovered him. Enlightenment philosophers debated him. 19th century scholars analyzed him. 20th century historians traced his influence. And 21st century students like you are learning about him right now. That's intellectual immortality. That's having ideas that matter enough that people keep engaging with them across millennia. How many people can say their work will still be relevant 2,500 years after they die? How many of our contemporary thinkers will still be studied in the year 4500? Anaximenes achieved something extraordinary. His ideas became part of the permanent conversation about the nature of reality, about how we know things, about how we should investigate the world. Key contributions. Air as arche, mechanism of change, empirical method. Okay, let's be specific. What exactly did Anaximenes contribute? What are his key innovations? 1. Air as arche. He proposed a specific observable substance as the fundamental reality, not too abstract like Anaximander's apeiron, not too limited like Thales water. A substance that's pervasive, subtle, and transformable. 2. Mechanism of change. He didn't just say air becomes other things. He explained how. Rarefaction and condensation. Quantitative changes producing qualitative differences. This is the beginning of mechanistic explanation in natural philosophy. 3. Empirical method. He observed nature carefully. He performed experiments like the breath experiment. He tested his theories against experience. This is the foundation of empirical science. These 3 contributions, a specific theory, a mechanism, and a method, these are what Anaximenes gives to the history of thought. The specific theory is wrong, but the approach, propose observable substances, explain mechanisms of transformation, test against experience, that approach is right. And it's still what science does today. Now, let me bring this all together. Let me tell you what Anaximenes' lasting impact really is. Anaximenes showed that the world is intelligible, that nature operates according to principles we can discover, that we don't have to accept mystery and divine whim. We can investigate, we can understand, we can know. He showed that observation matters, that we should look at the world carefully, systematically, honestly. That experience should guide our theories. He showed that we need mechanisms, that it's not enough to describe, we need to explain how things work. He showed that simplicity is valuable, that we should look for unified theories, for common principles underlying diverse phenomena. He got the details wrong. Of course he did. He was working 1600 years ago with limited tools and limited knowledge, but he got the approach right. He established principles that are still the foundation of scientific inquiry. And here's what I want you to take away from this lecture. Anaximenes matters not because he had all the answers. He matters because he asked the right questions, because he used sound methods, because he had the intellectual courage to challenge traditional explanations and propose something new. Every time a scientist proposes a theory and tests it against observation, that's Anaximenes' legacy. Every time we look for natural explanations rather than supernatural ones, that's Anaximenes' legacy. Every time we seek unified theories that explain diverse phenomena, that's Anaximenes' legacy. Every time we demand mechanisms, not just descriptions, that's Anaximenes' legacy. Pause, voice dropping, but maintaining intensity. He's been dead for 2,500 years, but his ideas are alive. They're part of how we think, how we investigate, how we understand our world. Not bad for a guy whose only surviving direct quote is about breath and air, right? More seriously, building to final statement. Anaximenes of Miletus. Born around 586 BC, died around 525 BC. Student of Anaximander. Third member of the Milesian school. Pioneer of natural philosophy. Champion of rational inquiry. Bridge between mythological and scientific thinking. He proposed that air is the fundamental substance. He explained transformation through rarefaction and condensation. He tested his theories through observation and experiment. He was wrong about the specifics, but he was right about the approach, and that's why, 2,600 years later, we're still talking about him, still learning from him, still grateful for the path he helped to clear. Anaximenes of Miletus. Wrong about air, right about everything that matters. Thank you.